Hello guys, this is Prime Concept. Now we're still considering the topic kinematics, uniformly accelerated motion. In our previous videos, we've been able to derive these formulas you can see on the board, the five equations of motion or equations of uniformly accelerated motion. Now this time I want to answer the problem or the challenge most students have, students that are preparing for exams, JAMB, WAEC, 100 level undergraduate students, SAT exam students, JPEP students, and so on. They've always asked me one of this major question: when I'm given a problem under uniformly accelerated motion, how do I know which of these equations to use? And how do I know when velocity is zero or which velocity is zero? These are constant areas of concern for students. In this video, I will be answering these questions, making it very clear to you such that you will not feel any question again after now. Now, one of the first things I want you to learn when you are solving physics, anytime you are given a problem in physics, be it kinematics or any other topic, first thing you want to always do is to write out the parameters that are given in that question. Don't fail. Say they tell you a particle is moving with a velocity 20 meter per second, you write out that velocity is given to you and the value is what? 10 meter per second. You write it out. They say a ball travels in air for 3 seconds. You know that 3 seconds represents what? Time. You write out the parameter. So this is the first thing every physics student should always understand. Write out the parameters of motion or of that question that are given. You write it out. So that is one thing. Then let's get into important points that can help us solve problems. So points to note. Number one, I've said it casually, so I won't be including it again, which is write out the parameters that are given. Now, very quickly, one of the things you want to know when you're applying this formula is if a question is given and they mention that an object starts from rest, an object moves from rest. The moment rest is mentioned, it means that the initial velocity is what? Zero. So when an object starts from rest, then u is zero. Please do not forget this. A car moves from rest. It means that initial velocity u is zero. So don't forget, rest from rest would mean that u is zero. Now, number 2 points I want you to note is when a question mentioned that a car or an object that is moving is brought to rest. An object is brought to rest. Note the difference. This one, the first one means starts from rest, but the second point means an object is brought to rest. It would mean that the final velocity is what? Zero. So when an object is brought to rest, v is what? Zero. So take note of these two statements. They look similar, but they are different. When an object starts from rest, u is zero. You won't have two of them simultaneously in a question. It will either be only this or only this, except you have two parts of the same question. Then you can have this. Otherwise, you will have only this in one question, only this in another question. They will not be together. So why this? When an object is brought to rest, the final velocity v becomes zero. And number 3 point I want you to note is that if a question requires you to find the total distance of a journey, say a car traveled, right, with whatever velocity it traveled with, then they now require you to get the total distance. Of course, for you to tell the total distance an object has moved would mean that the object has stopped moving. Because if the object is still moving, you cannot determine the total distance. So it means that For you to determine total distance of a journey, the object would have been brought to rest. So again, to find total distance of a journey would mean that the final velocity again should be what? 0. To find total distance traveled, V should be set to be what? 0. So you can say that number 2 and 3 are similar. So you want to find the total distance for a journey, then you have to set V to be what? 0. Or the total time of a journey, then you have to set V to be what? 0. So this is very important. Number 4 point I want to also mention is the point on deceleration. Now, very important, salient, but very important for you to understand. Now, first, you should know the difference between acceleration and deceleration. Acceleration means there is an increase, there's a change, an increase in velocity. Deceleration means there is a drop, there's a decrease in velocity. Usually, acceleration is positive and deceleration is what? Negative. So if you must take this into account, then this point is very important for you to note. Now, if a car or an object decelerates or brakes are applied to a car, then you should know that the bigger velocity becomes the initial velocity. The smaller velocity becomes the final velocity. Let me repeat. When a car decelerates, or they say a brake is applied to a car, then you would use the big value of velocity as your initial velocity, then use the small value as your what? Final velocity. Let me write it so that it will be clear to you. When a car decelerates or brakes are applied, the initial velocity the initial velocity is usually the bigger value. So I believe with this statement it is clear. Now let me explain it further to help you understand. Now say you have two velocities. One is 20 meters per second, and the second velocity in the same question is 40 meters per second. Now they say a car with this velocity is decelerating. They say find the deceleration. Let's say time is 2 seconds. Say this is decelerating. So you would quickly know, because they have mentioned deceleration, you would assign the bigger velocity. So initial velocity would take the bigger value. So U becomes 40 meters per second, then V becomes what? 20 meters per second. So this is what I'm trying to explain here. So when a car decelerates or brakes are being applied, then the bigger value should be the initial velocity. The smaller value should be the final velocity. So that when you solve using this formula, A is equal to V minus U by T, because this is the same formula you use for acceleration and deceleration, no different formula. So what do we have? I would have that V is what now? 20 minus U. And what is my U? 40, which is divided by what? 2. So I would have that A becomes 20 minus 40 is minus 20 divided by 2. This becomes minus 10 meters per second what? Squared. Right? Now please, you notice that our final result is taking a negative sign. That negative indicates that it is a what? Deceleration. So you don't have to come here and include negative sign again. Once you follow this, don't include, there's no need for any extra sign. So just follow these principles like I've explained them. Now with these very important points I've outlined, we're going to take one problem in this video. Subsequently, we'll solve more problems. Very quickly, let me drop the question. All right, now let's quickly handle this problem. Now the question says a body starts from rest. Very important. So what rings in your mind now? From rest would mean that the initial velocity u is 0 and moves with a uniform acceleration of 0.5. The acceleration is given. So A is 0.5 meter per second. You can see how I'm writing out my parameters. So once I write this out, to quickly bring to my consciousness which of the equations to use. An acceleration of 0.5. What distance does it cover in 10 seconds? So we're looking for the distance s. I'm writing it. Then the time for that distance is what? 10 seconds. So you can see the parameters I have. I have u, I have s, right? I have a, I have t. Now I mentioned in the important point that when they tell you distance, you need to set v as 0. So we're not going to use them simultaneously, v and u. So we're going to go with 1. You'll see we can solve this in a different way also. Now let's think of a formula among the 5 equations that have u, that have a, that have s and t, and you see that you can quickly solve it. So the equation that can do this is s equals ut plus half what? At squared. It has all the parameters we'll be needing. So s is equal to u, which is 0 times t, which is 10, plus half times a, which is 0.5, times time, which is 10 squared in this case. So 0 times 10 is 0, plus now half times half is actually 1/4, times 10 squared is 100. So this is simply going to be, 25. So this is going to be 25 meters. So our distance that is traveled is what? 25 meters. Is there a different way to solve this question? Of course, yes. We can solve this in a different way, right? Yes. Now let's quickly take another approach. Let me rub the board. All right. Now a different approach we can take for this also is to know that we can say v is u plus at, and we'll get our final velocity at this point. Now you should understand what this question is saying. So we have that v is equal to u, which is 0 plus a 0.5 times our time 10. So v becomes this times this, which is 5 meter per second. So this is our final velocity with which the body is moving. Now, if you recall, the fourth equation of motion we derived is s equals vt minus half at squared. So s is v, in this case 5, times t, which is 10, minus half times a, which is 0.5, times t, which is 10 squared. So I have this times this is 50, minus this times this, everything that will give me 25. So 50 minus 25 is what? 25 meters. So the same result as the previous one. So I can even solve this in more ways and we'll still get the same answer. Say you don't also like this, just to still show you, you can still do this. That s again is v plus u over 2 times t, and s becomes v, which is 5, plus u, which is what? 0, divided by what? 2. Then this multiplied by the time 10. So s becomes 5 plus 0 is what? 5 over 2 times 10. So 2 in 10 is 5. 5 times 5 is what? 25 meters. Same way. So we can solve this in so many ways. That is what I want you to really understand. So I believe that this concept at this point is clear to you. If there's any confusion, please drop it on the comment section and I'll attend to it. Do like this video, comment, and share with your friends. Tell them it is prime concept. Thank you.